For this next video, we're going to be going over talking about forces at an angle. If you have not already checked out the geometry extensions on SOHCAHTOA and the Pythagorean theorem, then please make sure that you guys check those out before you go on to finishing this video. But first, the Pythagorean theorem, a squared plus b squared equals c squared. We will occasionally be using this if you know what two of the sides are, and then you're looking for what the diagonal force is. But the main thing that we're going to be doing is SOHCAHTOA. So we know the angle that a force is exerted at, and then we know what we're pulling with 20 newtons of force at a 35-degree angle, let's say. So we should be able to figure out how much the force is pulling it up and how much the force is pulling it across, right? Or how much it is pulling vertically and how much it is pulling horizontally or in the x direction. And for this, we're going to need SOHCAHTOA. SOHCAHTOA is really just a helpful phrase in order to remember that the sine is the opposite. So if we're looking at this angle, which has theta next to it, which is a Greek symbol, if we're looking for the sine of that, we would need to look at the opposite side and then the hypotenuse. So let's say that we have the hypotenuse and we're looking for the opposite side. If I know this angle, I just plug it in here, rearrange that, and that should help me out figure out how much the force is pulling up. If I'm looking for the adjacent side and I already have the hypotenuse, then I could use cosine and just do the adjacent over the hypotenuse. So that angle, the cosine of that angle would be equal to the adjacent over the hypotenuse. We can also use tangent as well, which would be if we hypothetically have the opposite, then we could do, but we don't have the hypotenuse, we could do tangent to be like, okay, the opposite is this, what is the adjacent? So what am I going to use? Here's one example of a time that we can use this. So we have a 4-kilogram sign that is hanging from a boom supported by a cable connected to the wall. The cable makes a 30-degree angle with the boom. The boom here is just like what is sticking out from our brick wall here. So the question asks you, what is the force tension in the cable and what is the force the boom applies to the sign? So really we need to find out our force tension pulling up. And we also need to find the force tension in the x direction, right? And then that will kind of help us figure out how much the force push is. How much force pushes going out against that. One thing that we do immediately know as we draw this force diagram, though, we know that our force gravity is going to be equal to the force tension in the y direction, right? Because the sign is staying still. So however much our force tension is pulling up is countered by gravity. So I know those two are equal. In addition, I know that the boom is pushing out just as much as the force in that cable is pulling it towards the wall. So I know that those two forces are balanced. Otherwise, the object would be accelerating to the left or to the right. So I know that those forces, again, are equal because this force, this object is balanced. So there are a couple different approaches that we can have to this. The first thing that I can easily do is if I know the force of gravity, that immediately tells me that my force tension in the y direction is also that, right? Because we just talked about how those should be equal. So if it's a 4-kilogram sign, I know that the force gravity is 40. Therefore, my force tension going in the y direction is 40 newtons. So that gives us one side of this triangle now, right? So I can't use the Pythagorean theorem because I don't have the other side of it, but I do know the degrees here, right? It's a 30-degree angle here, and I know the opposite side of that. So then I can figure out my adjacent side, and I can also figure out the hypotenuse. So we're going to start with sine, right? The sine of 30 is equal to the opposite over hypotenuse. In this case, the sine of 30 would be the force tension in the y direction over the force tension. I'm going to rearrange this to get force tension, so our force pulling up and to the left. That force tension is going to be by itself So I move the force tension in the y direction to the other side. In this case, that is 40. So I get 40 divided by the sine of 30 should give you the force tension, which should be 80 newtons. So I know my force pulling up is force tension, 80 newtons. Okay. Now that I have the other side, I could use the Pythagorean theorem, or we could just do we could do cosine, we could do tangent. Now there are a variety of different options that we have here, but I know the force tension going up is 80 now. Also, I do want to point out, please make sure that you have your calculator in degrees as we go through this. Otherwise, you are not going to be able to figure out the correct value for sine of 30 degrees. So now I'm going to say we're going to go down here. I chose to do tangent. So tangent is the opposite over the adjacent. Rearrange that to get the tangent of 30, force tension in the y direction divided by the tangent of 30 should give me the force tension that's pulling it in the x direction. You plug that into your calculator, 40 newtons divided by the tangent of 30. You should get the force tension in the x direction is 69.28 degrees, or not degrees, newtons. And then a reminder that the force tension in the x direction is pulling to the left just as much as the force is pulling it to the right. So that's how much force the boom is pushing it out. And this is just one example of using the forces at an angle. We're going to go through a couple more examples of this on your homework, and then there will be an example of this on the review as well. Please do understand that I know that this is some complicated stuff, but really starting with a force diagram should help us. And as soon as I knew that these forces were equal, that made this problem solvable, right? If I didn't have the force diagram at first, this problem would have been significantly more difficult. So anyway, please let me know if you guys have any questions on this, and have a good one, guys.